Also, what is a mean? Like the average.
What does it mean?
The mean,
The
like
mean?
yeah.
How deviant and mean are your data? Introduction and Basics Part 1, The Full Story, is an episode of the Degrees of Freedom Project, videos on chemical and thermal principles. Definitions and additional details can be found in the webpage link in the description.
Also, what is a mean? Like the average.
What does it mean?
The mean,
The
like
mean?
yeah.
Well, the mean is the arithmetic mean, or which?
Oh yeah.
The arithmetic mean? It's when you sum every number and divide it by the amount, every data point you have by the number of data points you have.
Mean is the average of all experimental test values.
Oh, a mean is the average of all of your data points that you collect.
The mean is usually like the average of maybe like the sample or like population, whatever you do in the experiment.
So a mean is the average of all of the values in a data set. So you take all the values and you add them up together and you divide by the total number of values. So if I have 5 values, you divide by 5.
Why does an experimental engineer need to know what a mean is?
I feel like anyone should know what a mean is, but if you're an experimental engineer, I'm assuming that you do experiments with stuff and you need to know, like, what's the average outcome of your experiment, I guess.
They would need to know what a mean is so that they can understand their data in a broader perspective outside of just the individual data points.
I would say an engineer needs to know what the mean is just to get like an overall like average of the results that can be like very telling of like how their experiment's going.
I think they need to know what a mean is because that is a good representation of all the data. It is where the data is centered around. So, well, not necessarily centered, but it is the average of all the data.
Well, if you're looking at data and you want to see like central tendency, the mean is a really helpful marker of that. It can tell you like where the data centrally lies, which is really important if you're looking at a data set and want to understand it better. But you can also look at other ways of looking at central tendency, like the median, which is basically the middlemost point in your data set, or the mode, the most frequently answered value.
A responsible engineer will always estimate and indicate the uncertainty in any measurement. In addition, these measured quantities are often used to calculate other quantities. For example, the mass and velocity of an object are used to calculate the momentum and kinetic energy of the object. A future video will teach you how to propagate the uncertainty. Again, a responsible engineer will report the uncertainty in the calculated quantity due to the uncertainties in the measured quantities.
Do you personally know anyone who cares about the difference between a population mean and a sample mean?
A population mean and a sample mean? Well, I care about the population.
Yay!
I probably do. I can't name them off the top of my head. Okay.
I could probably name one person, and that's my AP Stats teacher in high school.
I care about that.
So I do psychology. I'm a psychology and I'm interested in research. So that's actually a lot of what I do. I work with a lot of like population versus sample. So all my experiments that I help run, I work with sample means, but you want to translate that to the population. So looking at differences between the two is really important.
Do you know what the difference is?
So a sample mean is when you take a small group of people and you see what the average is. A population mean is when you take the entire population and see. So it's a different scale of the mean.
No, I can't say that.
Oh, okay. So obviously you do.
I do. Yes, I do.
Okay.
Yes, a sample mean is within like a certain experiment, I think. And a population mean is like from a greater group.
A sample mean is just the average from one sample, and the population mean is like it's for the whole population, and they like you can calculate them differently.
First, some definitions. Statistics posits the existence of a true value for a measured quantity, sometimes called the true mean or the population mean. And this value is given the symbol mu. We almost never know the true mean. The true mean or population mean is the value you'd get if you had an infinite precision ruler, or if you weighed everyone in a given place on an infinite precision scale and took the average. Also, if we had a table of infinite precision weights of everyone in that place, we could calculate how these values spread or distribute themselves about the true mean. One metric that characterizes the spread of these values is the true standard deviation, or the population standard deviation, given the symbol sigma. Again, like the true mean, we almost never know the true standard deviation. Instead, we have to come up with a method to estimate the true mean and true standard deviation, and make some guesses about how close these values are to the truth. We almost never know the truth, but we believe that it exists, and we make our best estimates of what the truth is, given the limits of time and money we have at our disposal. Let's begin by making a set of measurements, x1 through xn, of the quantity of interest. For each sample measurement, we have one equation. For example, x1 equals 43.15. So for n samples, we have n independent equations. We calculate the sample mean, or simply the mean of these measurements, by summing them and dividing them by the number of measurements. We call this sample mean x bar and use it as our best estimate of the true mean, mu. Our goals are to determine the value of x bar and to determine how close x bar is to mu.
For a set of data, can you explain the difference between an error and a residual?
Well, I know what the error is. I don't know what the word residual means.
No, I can't. I don't know what a residual is.
No, I can't.
Is the error calculated before, error calculated by the experiment and residual built in?
Residuals are like, it's like the difference between like an estimate versus your actual value, and an error is kind of just like, I don't have like a definition of error, but it's just like the error you account for in it.
If we knew the true mean or population mean, we could calculate the error in each of our measurements as the difference between the measurement and the true mean. The error is usually given the symbol epsilon. Again, the error is the difference between the measurement and the true mean. So we would have a set of errors, epsilon 1 through epsilon n. However, we don't know the true mean, only the sample mean. So we calculate the residuals, which are the differences between the measured values and the sample mean. The set of residuals is then E1 through En. In other words, the residuals are estimates of the errors based on the sample mean instead of the true mean, mu. The sample variance is calculated by summing the squares of the residuals, E1 through En, and dividing by the number of samples minus 1, n minus 1. So it's essentially the average of the squares of residuals. It's given the symbol s squared. So why n minus 1 instead of n? If we knew the true mean, each of the errors would be independent, but we're using the sample mean, which was calculated from all of the samples. So the residuals aren't independent because we're calculating residuals from both each sample and from the sample mean, which was calculated from each sample. We lose one degree of freedom, or an independent equation, by using the sample mean. So we divide by the remaining degrees of freedom, n minus 1 for the sample variance. The true variance would be the sum of the square of the errors, not residuals, divided by n, and is given the symbol sigma squared. Estimating the mean causes a minor but non-zero increase in the sample variance compared to the true variance. Most people really dislike dealing with these quantities and don't devote too much time between distinguishing between errors and residuals. So you will see both x bar and mu used for the sample mean, and both s squared and sigma squared used for sample variance. On those rare occasions when such distinctions are needed, it's up to you to determine what is being used. The true standard deviation is the positive square root of sigma squared, given the surprising symbol of sigma, and the sample standard deviation is the positive square root of s squared, also known as s. S by itself doesn't answer the question of how close our estimated mean x bar is to our true mean mu, but it is useful for other things.
If we assume our set of measurements is roughly Gaussian, and we always assume our set of measurements is Gaussian, S can let us make some useful predictions. If we were packaging cereal and had set our automatic fillers to fill a certain value, and then we sampled and weighed some of the filled bags, we could get an estimate of the mean or set point of the filler. But we would know that roughly 68% of the bags would weigh within plus or minus 1 standard deviation of the set point, and 32% would be further away than that. This number would give us a handle on how many complaints we might get from disgruntled customers complaining that there wasn't enough cereal in their bag. However, we still don't know how close our set of measurements is to the true value. We will discuss this calculation in part 2. The key takeaways are: 1. Responsible engineers always estimate and report the uncertainty in any measurement or quantity calculated from measurements. 2. The most common estimate for the central value of a set of measurements is the sample mean. 3. The most commonly reported value for the spread of a set of measurements is the sample standard deviation. 4. Most people don't know or care about the difference between the sample mean and standard deviation and the population or true mean and standard deviation. Thanks for watching. This video was brought to you by the DOFPro team.